Recall that in the first part of this lesson, we derived the formula for the area of a regular hexagon in terms of its side length. We said that that area was the area is equal to x squared root 3 over 2. And we just replaced the x with s, for s to symbolize or stand for the span. So moving back to 19b, we can easily find out what the span is of this regular hexagon. And that's what we're asked to do by taking this equation, s squared root 3 over 2, and setting it equal to the area, which is 32 root 3. And if we do the math, we multiply both sides by 2, we end up with s squared root 3 is equal to 64 root 3. And then divide both sides by root 3, and we end up with s squared is equal to 64. S is equal to plus or minus 8. And we know that the span cannot be a negative value. So S, the span, is equal to 8. And that is our answer. In problem 20a and b, we're asked to find the apothem and the area of a regular octagon. Now this is a tricky problem, and you have to think outside, so to speak, of the octagon. And the way that you can solve this problem, and there may be other ways to solve it, is to draw two auxiliary lines extending from consecutive vertices of the octagon. And these are supposed to meet at right angles, and also will be the same length. So we'll call these sides that we just created x. We know that this side length here is 10. It's the same all the way around a regular octagon. So now we have an equation to figure out what the value of x is, and that's just x squared plus x squared is equal to 10 squared, which is 100. So 2x squared in this case is equal to 100. X squared is equal to 50. And x is equal to plus or minus root 50. We know that x cannot be a negative value. So we end up with x is equal to 5 root 2 as we factor out perfect square of 25. We also know that the distance from here to here, half of the side length, is going to be 5. So this length, which is also the same length as the apothem, is going to be 5 plus 5 root 2. Now we can figure out the area of this octagon, because we know that 1/2 of the, we'll say the perimeter first, times the apothem is going to be equal to our area. So we have 1/2 of the perimeter, which is a side length of 10 times 8, 1/2 of 80 times the apothem of 5 plus 5 root 2 is equal to our area. Or we have 40 times 5, which is 200, plus 200 root 2 is equal to our area. So we found our apothem at 5 plus 5 root 2. And then from the apothem we were able to find the perimeter. In the next problem we're asked to find, number 23, we're asked to find the area of the shaded region in blue. Now we can say that the area of the shaded region in blue is just the area, total area of the triangle, minus the area of the square that's inside of the triangle. And that equals the area of shaded. Well, we recall that we have a formula for the area of an equilateral triangle, and a regular polygon, a regular triangle, is going to be equilateral. And that formula is going to be s squared root 3 over 4. Well, we know our side length is 12, so we have 12 squared, which is 144, root 3 over 4, which reduces to 36 root 3. So that's the area of the triangle. Now we want to find the area of the square. And that seems to be a little complicated, but let's try this. Let's identify that this length here, we'll call this E, AE, as x. We'll also know that, we'll say this is F FC is also going to be x, because this distance here subtracted from 12 will equal a certain length, and divide that in 2, we'll have 2 x's. We also know this is an equiangular triangle, so this is 60 degrees. This angle here, A, is 60 degrees, and this is 30. Now, if the side opposite the 60-degree angle, the 30-degree angle is x, I know the side opposite the 60-degree angle is going to be x root 3. Since this is a square and all of the sides are congruent, I know that this bottom part of the square is also going to be x root 3. So now I can figure out what the value of x is, because it's just 2x plus x root 3. So we write that in here, 2x plus x root 3 is equal to 12. Now here's the tricky part. A lot of people are confused about how to isolate x in this case. And we do that by factoring the x out of the left-hand side of the equation, and we're left with x times 2 plus root 3 is equal to 12. Now simply we divide both sides by 2 plus root 3, and we're left with x is equal to 2 plus root 3. Now recall that in math we don't want to have a radical in the denominator, so now we must multiply both the numerator and denominator by the conjugate of the denominator, which is going to be 2 minus root 3 over 2 minus root 3, and we're left with 24 minus 12 root 3 over 2 times 2, 4, plus 2 root 3 minus 2 root 3, that equals 0, minus root 3 squared, which is just 3. Or this is equal to 1. So we're left, in fact, with a value for x as 24 minus 12 root 3. Now, in order to find the area of the square, we have to multiply this entire equation by root 3 and then square that value. Okay, and we're going to do that on a separate page. So 24 minus 12 root 3 that's x. Now remember, it was x root 3 was the side length, and we're going to square that entire amount. And let's just write in, this is the area of the square. So first what I want to do is I want to multiply root 3, distribute it at both values. 24 root 3 minus 12 root 3 times root 3 is going to be minus 12 times 3, or 36. And now we're going to square this value. So let's write this whole thing out. I'm going to take off the square here. And we're going to multiply this by 24 root 3 minus 36. Well, picking up a calculator, I see that 24 times 24 is equal to 576. And I know root 3 times root 3 is going to be just 3. So using the formula method, I'm going to multiply the first values. Then I'm going to multiply the outside values. So that would be minus 36 times 24 root 3. Then the inside, minus 36 times 24 root 3. And then the last, which is going to be negative 36 times negative 36, which is plus 36 squared. So 576 times 3 is going to be 1728. And this, if I combine the two middle equations, I have 72 times 24 root 3. And then I'm going to add that to 36 squared, which is 1228. 96. 1728 plus 1296 is going to be 3024. And then 72 times 24 is going to equal 1728. So I'm left with minus 1728 root 3. Now recall this is the area of the square. So I want to subtract this from the area of the triangle. So we go back to our values and we see that the area of the triangle is 36 root 3. So now I have 36 root 3, the area of the triangle, minus the area of the square, which should give me the area of the shaded region. And when I distribute the negative, I end up with 36 root 3 minus 3024 plus 1728 root 3. And that leaves me with 1764 root 3 minus 3024. And that is the answer for the area of the shaded region of the triangle. In the final problem, we're asked to find the area of triangle ABC, and we're given coordinates to find that. So, and this, by the way, is problem 26. So all we need to do is find the area of the rectangle, and then subtract the individual triangles 1, 2, and 3 from that area to find the area of ABC. So first we find the area of the triangle. Now the height of the triangle is going to be the difference in the y values. So I have 9 here and 1 here, so I know the height is going to be 8. And I'm going to multiply it by the width here, and I know that the left corner is going to be, and I'm going to subtract the x values. I know the left corner is 2 and the right corner is 8. So I know that the width of the triangle is going to be 6. So the area of the rectangle is 48. So let's just write out area of ABC is equal to area of the rectangle, we'll call it R, minus the area of triangles 1, 2, and 3. So let's figure out the area of triangle 1 first. Area of triangle 1 is going to be the base, which is the difference in x values. In this case, I have 2 here at A and 4 here at B, so my base is going to be 2, and my height is the same, it's 8. So I have 1/2 of 2 times 8, which is going to equal 8. Area of triangle 2 is going to be 1/2 of the base here, which is going to be the x values 4 to 8, which is 4, times the change in the y values, which is 9 to 3, which is 6. So I have 4 times 6, and I take half of that. That's going to equal 12. And then the final area of triangle 3, is going to be the base. We'll call the base A to this vertex here, which is going to be the difference in the x values, which is 6, times the difference of the y values, which is 212, divided by 2 is 1/2 of base times height, which is going to be 6. So the sum of the 3 triangles is going to be 26. I subtract that from 48, and I end up with 22 units squared as the answer